started out doing actually web application dev work back in the day, became a pen tester, did a bunch of pen testing for a bunch of different companies, then kind of got honestly tired of the wham bam thank you ma'am style of pen testing. So I went internal and started the product security team at Rackspace, which we grew from me and a manager to 12 people. And then from there, I worked at Pearson, which was kind of an amazing thing. We went from 44 assessments per year to 414 over the course of 2 years, primarily due to automation work I did, which was pretty fantastic. Also did some product security work for Duo Security. So that's kind of my background for what it's worth. Let you know where I'm coming from. So let's talk about the agenda. So I'm going to first talk about why API security does not equal app security. And then I'm going to go into what I would call the 3 critical features of a functional or useful or productive API security program, right? That's API security posture, runtime security for APIs, and then also testing or shift left. Shift left is kind of got to be a trite term these days. I remember using that when I worked at Rackspace 8 or 9 years ago. But it's really gotten the buzz these days. So, hey, shift left. Quickly talk about some other considerations, and then I'll drop into key takeaways, and that should do it. Also, I want to have a moment of silence for our poor, unfortunate souls that work at Java shops right now, our fellow technologists, right? It was bad enough to have log for shell over Christmas, but it seems just in time for Easter, we have spring for shell. So God bless the people who work in Java shops. They're having a rough time these days. And then please ask questions in the chat as we go. I would really appreciate if this was, and I think it would be much better for everybody if this was an interactive thing where people ask questions so that we can actually have a nice dialogue going as best as possible. I'll happily repeat your questions for the posterity of the recording. But I'd much rather have this be a thing where I answer your specific questions versus me just talking at you for 50 minutes. And I've got a nice wide, ultra wide monitor, right? So I can see the questions easily. So please ask away. I will happily answer them. All right. So why is API security not the same thing as app security, right? For our first topic to cover. So APIs, they seem simple, right? You look at Wikipedia, right? The definitive resource for all things, right? And an application programming interface is a connection between computers or between computer programs, right? In the sort of webby internet world we live in, right? You have your program, I have my program. Let's say my program has some sort of like REST API. You'll make a request to get something and I will send you something, right? And the languages that those are written in doesn't matter if you like Python and I like Go or Ruby or whatever, Java, God bless you. It doesn't matter, right? It really doesn't matter. And this seems super simple, right? It's just like I make a call over a network and you return some data and it's all pretty straightforward. Well, that's not really the case when you start to do these things at scale, right? If you have a web application that's backed by a bunch of API calls, right, you probably have a WAF in place. If you have a mobile app that also uses those same calls, it'll more than likely go through some sort of API gateway, right? There's probably an IDP managing the user permissions, maybe an API management control plane, right? That also helps manage the API gateway. You have a whole bunch of services in the back end. Those services may call other services that may or may not be on-prem, maybe in different providers' clouds, maybe in multiple providers' clouds, right? So this junk gets really complicated really quick when you start to do it at any kind of scale. And if you have an endpoint with 20 or 30, or an API endpoint with 20 or 30 calls, that's not so bad. I remember working with a healthcare that one of their APIs had 435 methods. So paths, right, that I could call, let alone the multiple supported HTTP verbs for those 430 some odd paths. So these things get complicated really quick. And you don't have to take my word for it. There's a wonderful website, API Landscape at APIscene.io. And actually, I have that in another tab here, right? And if you look at this guy, here are all of the logos of companies and products and open source things and what have you that have some sort of interaction in the API world. So, oh my, there's lots of these things going on. And then APIs are going to grow, right? They can grow in breadth or in depth, right? Growing in breadth just means you have another API endpoint generally exposed through an API gateway. It could just be a new endpoint added to an existing API service. And then depth. This is where an API takes in a request, and then to handle that request, it may call back into some internal APIs to pull the data it needs to make whatever response is required for that initial call, right? And these are usually internal. If you have microservices or you're doing cloud stuff like I did at REC, these can spawn off a whole bunch of different calls, almost like a spider web of calls that happen back behind the scenes. And then just to level set stuff in case I say these things and you're unfamiliar, there's this idea of north-south traffic. This is the concept that a client is making a request from outside of the organization into the organization, usually through an API gateway. So you can think of these as external or outside of the data center, although whatever data center means these days with cloud is kind of an interesting concept, but you get the idea, right? It's going from not your systems not under your control to systems under your control. And then east-west traffic is usually referred to for internal APIs, right? And a lot of times these don't go through a gateway at all. They are simply API 1 calls API 2 that calls API 3. And these all, the kind of key idea with east-west traffic is that it's inside of a data center. It's from one system you control to another system you control, generally speaking. And I shouldn't have to say this at an API Secure conference, but they are becoming the center of digital life. I was surprised. This was earlier this fall when I got the number from Akamai, if I remember correctly. 83% of global internet traffic is initiated by an API call. I would have not have guessed that high. I would have lost that bar bet for sure. And then digital transformation, if nothing else, spurred on by the COVID pandemic, right? A lot of companies are trying to do a digital transformation, trying to do the zero trustee kind of thing, right? And most of those things, most of digital transformations involve API calls, right? Because you're doing a lot of SaaS, a lot of cloud. And then cloud infrastructure, 43% of companies are running more than half of their workloads on public clouds, and you can't interact with the public cloud without making API calls, right? And APIs are great. I mean, I love them as a developer. I use the heck out of them to do security automation. Years ago, I grumped on Twitter about, please, you security tool vendors, put APIs on your things because I'm tired of logging into your web front end and having 10 tools and 10 different stupid web UIs I have to log into. I just want to automate it by calling APIs, right? And that's somewhat come to pass, which is a great thing for automation, not such a great thing for the security state of affairs. And then for what it's worth, Gartner said by 2022, API abuse will be the most frequent attack vector. That seems to have played out rather well this year. I don't know if I'd call that well, but it certainly seems to have played out. And then public APIs, right? They represent a significant security gap, and it's usually silly things, honestly, like misconfigured APIs that cause these problems. And the kind of the wall of shame on half of my slide here are all companies that had very public vulnerabilities and exposures of API security issues. And some of these companies are companies that have serious cash and engineering behind them, and they can't get it right. So this is kind of a tricky situation we find ourselves in. APIs are 10% of API, less than 10%, excuse me, are actually subject to testing in production. And for some of the companies I've talked to, I've seen things like, yes, we do test our APIs. Some of these are my friends that are in the AppSec world. You're asking them about this, and they say, oh yeah, we test our APIs. Well, how do you test your APIs? Well, we have a pen test of our web app, and therefore, since it's backed by an API, de facto, the APIs get tested. Well, they sort of do, right? Yes, if there's a one-to-one mapping of all of the exposed API calls to everything that happens in the web app, then yes, you could get, I guess, complete coverage. If there's anything on the web app side that it does to sort of constrain or do any kind of filtering of those calls back to that API, then maybe you're not getting full coverage. And a DAST tool, especially a DAST automated tool, probably isn't going to do right by the API. You'll get some coverage, and it's better than nothing for sure, but it's not what I would think of as completely understanding the security posture of that API. Less than 5% of organizations think they have the sort of pace and skill set to keep up with the API growth. Over half of the organizations rank API security as their top 5 cyber risk. And then over 55 breaches already in 2022. So yikes, right? This isn't a happy place to be, sort of. I mean, well, maybe as a tool vendor it is, but but like there's some serious problems going on here. And then an interesting thing that NoName did is we hired Alyssa Knight, who also did a talk at this event earlier today, actually. We hired her to do some research for us. That we didn't guide the research except for we wanted it over API security. She looked at banks and cryptocurrency exchanges. Of the 55 mobile apps that she looked at, 54 of them had hard-coded API keys or tokens, which is a bit spooky. All of the apps were vulnerable to, as she called it, woman-in-the-middle attacks, right, where I could intercept their TLS connections with a proxy, right, put Burp Suite or something in line and have some fun with those mobile apps. Also, all of the mobile apps had BOLA and authentication issues. Auth-N and Auth-Z is unfortunately plaguing APIs. I think it's mostly, well, I would attribute it to 2 factors. One, you have a program-to-program authentication, which is very different than a human-to-program authentication. And 2, in the web world, in the web app space, browsers have done a whole bunch of things over time to make them significantly more rugged of environment to run code in. And if you're talking with a human, they can do things like MFA, etc. Right? But if I'm an application talking to another application, I don't have that ability. And then one other interesting thing that came out of this research that she did was that one of the banks had outsourced development of this code, and turns out that same outsourcing shop had done the same kind of work for a whole bunch of other APIs. And so suddenly you find one issue in one company's API, and you can follow the bouncing ball to all of the other people who had used this outsourced development company, and they have the exact same issues, right? Because they're basically just reusing that code base, right? Spooky. And this is up on our website if you want to grab it. It's not NoName focused. I mean, our name's on there because we paid for it, but the research is just plain open research. It's not focused on NoName in particular. It's a good read. I quite liked it. So app security tooling provides partial coverage, right? You may have existing controls in there, your AppSec controls that your existing program has, and they're probably pretty good, we would hope, right? But when you add API into that, you're not catching all the things, right? Grabbing water with your hands, you're going to catch some of it, but you're not going to catch it all. And what do I mean by this? Well, what I mean by this is there's some overlap, right? SAST that looks at traditional app development also can look at API, right? That's easy. Threat modeling works for apps, works for APIs. SCA, same thing, works for apps, works for APIs. WAF, depending on the quality of your WAF, it may help you a little bit, particularly in the rate limiting and those kind of really blatant attacks, but it probably doesn't understand APIs at the level you need. DAST testing, depending on your DAST tool, may or may not really understand APIs, may or may not be providing you full coverage. Your SDLC likely helps you with both. You may or may not be spending enough time in the SDLC on the API side of the house, particularly if you're new at this, right? And then you flip to the other side and you look at API sec tooling, and you've got all these different things happening that are necessary for APIs that you didn't have to mess with your traditional, air quotes, AppSec program, right? OAuth 2, OpenID, JWTs, gRPC, API specs, right? The open Swagger or open API specs, right? You do have to have an inventory of both your apps and your APIs, so there's some synergy there, although they may be different inventories. You didn't have API management tools in place for your traditional apps. Anomaly detection is very useful for APIs. can be also useful for web apps. Rate limiting is obviously a crucial thing, right? So there's all these other pieces that you sort of need to augment an existing AppSec program with to get the kind of coverage you need to make sure that your apps are going out the door securely. And so I took the OWASP API top 10, and God bless OWASP. I did some, when I was doing this research back this fall, I looked on the OWASP website, and there were actually 13 OWASP top something lists, right? So there's actually, you could have a top 10 of the top 10s of OWASP top 10s, right? Which is a bit sad. The two big ones, honestly, are the original one, the web application focused OWASP top 10, the one from 2007. And then the OWASP API top 10 is the one we're talking about today, because guess what? We're at APIscure. So if you look at the different API top 10 issues, different aspects that you probably have in place already will help you somewhat, right? If you have secure coding and you're doing the right thing there, that can help you with a subset of the API top 10. If you have a WAF in place, it can help you some, maybe minimally or partially, for other portions of the API top 10. If you have an API gateway, this is another case where it'll help you with some of them, but it may not give you only partial or minimal coverage for other parts of them. And the idea behind this slide is, hey, you've got some good things in place in terms of controls for your traditional AppSec program, but you probably don't have the coverage you think you do without upping your game a bit. And by the way, I should mention this. I did a webinar called Are You Safe from OWASP number 11, because I don't know why people get so fixated on the top 10. It's called the top 10 because there's more than 10. So please don't get owned by something that's not in the top 10, right? You need a full protection, full coverage. Now, luckily, if you look at the OWASP top 10s over time, they've gotten much more broad, right? They started to be well, if you look at the 2007 one, it was very specific. SQL injection, right, was a thing. Right now, we just talk about injection in general. So it is nice to see the top 10s over the years get more broad in what they cover, but there's still gaps, right? There's still things that can happen that aren't part of the top 10. So I like this webinar. I did it, so go figure I'm a little biased. So we've laid the groundwork about why API security is different and not quite the same as app security. So what are the three critical features that are required to have a sensible and good API security program? And for this, I want to change, or at least set what I think to be the definition of an API. And this is really, if you think about it from a security perspective, you have to think about APIs slightly differently than just a path, right? No, most people think of an API, if I want to call the users API, it's, /v1/users/whatever, right? It's just a path. But really, from a security point of view, you need to think about the method, right? Is it a get? Is it a put? Is it a post? Is it a patch? What is it, right? The host that API is running on, right? Example.com versus test.bigcorp, and then the path, right? And if you take all three of these into account, then you can start making really good security decisions, right? Because a get to all users, right? This example.com v2 users/all, right? So asking for a list of all the users is very different than sending a delete to that same host and path, right? If I want to delete all the users, that's a bad thing. That's a much different thing than just giving me a list. And maybe I don't want to expose my user list, and that has some security context as well, but it's certainly, I don't think, as bad as making all your users go away. And then in the second example, right, I'm adding an admin user, right? I'm posting to uat.example.com/v2/user-admin. So I'm adding, presumably, a admin to a UAT system. That's a very different security event, right, than adding an admin to production, right? So you really have to think about API and the definition of APIs, particularly when you're evaluating tooling, is to make sure they understand APIs at all of these levels. Because if they don't, those gaps are left for you to fill, and I'd much rather have a tool fill those for me and use my human brain for those more important security context-driven decisions and risk decisions. So API security is like an onion. There's lots of layers. So let's talk about those layers. So I like the 3 layers, 3 pillars, 3 fundamental parts. Kind of doesn't matter about the wording. But what are the 3 primary things you need to think about when you're creating an API, excuse me, I've said AppSec for far too much of my life, an API security program, right? You need to understand your API security posture. You need to have API runtime security, and you need to do API testing or shift left, whatever you want to call that. And so this is kind of the, what do I have in very broad terms? What's currently running and what does it look like? And then testing, I would put in the bucket of how do I make sure that I don't add to any security technical debt going forward, right? And obviously, like any kind of testing thing, the closer you can get this to a person at the keyboard knocking in code and calling it done, the better, right? You don't want this testing to happen in prod, although it doesn't hurt you to test in prod, but obviously if you can catch issues earlier, you're much better off. So let's talk about that first pillar. This is API security posture, and this is to get a broad overview or understanding or holistic view of your API landscape. Like what's going on? What all APIs do I have in my company that I need to understand and get a handle on? So obviously you need an inventory of every API, and this isn't just like, here are my 10 servers that have APIs on them. I need this in what I would consider my security control definition, right? What host, what path, what method, right? You need all 3 of those really to get an inventory, a true inventory for risk decisions of your APIs. And then of those APIs, which of those are going through an API gateway, right? Presumably if you have one, right? And which ones aren't? And is that okay? And are those legacy ones that predate the gateway? Or are they zombie ones? Or what are they, right? You need to understand that. And then you also need to understand which are internal only APIs, right? If I have an east-west communication pattern in between 2 APIs, that's great. But if a public IP ever hits it, that's a problem, right? But until you know that that should only expect internal IPs hitting that API, you may or may not be able to make that decision or make that call or even notice that event. Oh, love it. Yay, I got a question. I wish I could give you a prize. I'm going to give you a virtual thumbs up. How do you inventory all API? I'm going to talk about that in a bit. That is really tricky. I've had to do this in the past, honestly, manually when I worked at Rackspace. The product security team was in charge of everything from the iron up that ran Rackspace's cloud, which included inventorying all the APIs. And quite honestly, we spent one person who was an FTE, and they spent about a year doing threat models of all of the APIs that made up our cloud, all of the pieces of the products, and they were generally all APIs that made up our cloud. And that took a year. Now there is tooling that will do this for you. And if you can, that's fantastic. The better of the tooling, I'm kind of tipping my hat for a future slide, but the better of the tooling will watch the traffic and then generate that for you, right? That shouldn't be something where you're, God help you, opening up a spreadsheet and writing down APIs. Right? If you're doing that, that's better than nothing, and God bless you, but you really should be trying to do it in a much more programmatic and automatically updated way, because it's almost like the idea of painting a bridge, right? You start on one side, and by the time you get to the other end of the bridge, you just got to start over again because it takes you so long to do that. And you sort of manually keeping inventory is unfortunately a never-ending problem. In some places too, where you may get some benefits is if you're doing this in cloud. One of the nice aspects of cloud is they have APIs that will tell you all of the stuff that's deployed. And particularly if you have sensible tagging of those deployed assets in whatever cloud provider, right, you can use those tags to give you that inventory in a programmatic fashion, which is fantastic. So thank you for the question. I super appreciate that. So and then now that you have this lay of the land of what APIs exist, you need to map the data that's going into and out of those APIs, right? And understand and put that data that you found into classifications, right? Is it PCI data? Is it a credit card? Is it authentication or authorization data, right? How many users have that data? What's the volume? All of that kind of stuff, right? You need to understand, because I don't care how big your group is. And I had 12, which I thought was a pretty big group at Rackspace, although considering the number of developers, that ratio was horrifically bad. Regardless of how big your group is, you have a limited number of people on your team that you can put at problems, right? Focus on problems. So if you can get a list of the API inventory and the classification of the data, you have the two sort of fundamental things to take what would be a guess at the most important thing to do and drive that to a decision about the most important thing to do, right? And really the difference between a guess and a decision is how much information you have, right? If you have no information, you have to guess, you're forced. If you have all the information, you can actually make a well-informed decision. And so I like to think of posture as the who, what, and where, like who's calling the API, what data is the API receiving and sending, and where did that call originate? And this is particularly important if you want to distinguish between north-south and east-west or internal-external calls for APIs. Yeah, oh, sorry. Fat-fingered my slide advancer. So API runtime security, and this is getting a handle on what looks normal or what is normal for your runtime environment for your API. So just understanding what traffic, what calls, what clients normally interact with an API. And so this is basically watching or inspecting the traffic. Depending on the tool you choose, these can be inline or out of band. You may or may not have to have an agent on box, depending also on the tool. And the important thing here is that whatever tool you choose, you need to make sure that it understands all the types of API traffic you're going to have, right? Do you have only REST? Do you have REST plus GraphQL? Are you thinking about maybe next quarter doing gRPC? Well, you should probably pick a tool that understands all those different ways that APIs can talk, right? So that you have you have true visibility across what's happening in runtime. And so now that I can see and inspect and watch the traffic, this is where things get interesting, right? I can now start creating behavior-based models of traffic that define what normal is, and then using heuristics or ML or AI or whatever you want to call it, I can find anomalies. I can find things that don't match the patterns, right? And ideally, this is a continually learning model, right? As you add new API endpoints or maybe change parameters, the model can learn as it goes. And then really ideal, and to our first question, how do you inventory all the APIs? If you have something watching the API calls, that same tool can then feed back into your posture, right? If it sees all of the traffic going to APIs, it's not that big of an ask to have it also list out what it saw and give you basically a map that it creates based on running traffic. And then now that you have visibility into the traffic and some kind of modeling of what normal is, now you can start setting thresholds for what's abnormal and triggering alerts, right? And so these can be things like policies on data, right? I never want to see a credit card come out of this API, right? Or these health records should only be in the east-west traffic, never go north-south, right? Or just have abnormally large volumes of data. And this could be large number of requests, or each request is generally a couple of K and suddenly get a meg big request. That stands out like a sore thumb, right? And so now that I have policies and alerting, I can have responses. And sort of the things I've seen are sort of three choices. You can have a manual response where it lights up, or puts some UI element in a web interface or web admin panel. It's kind of great, but it's not that useful, to be really blunt. Semi-automatic, what I call semi-automatic, would be the ability to catch an alert and then drop a ticket in a ticketing system, ServiceNow, Jira, whatever you use, right? And say, hey, I want a human to validate that this is actually a true event, and then take whatever corrective action is there. And then automatically would be to see an event. I'll just give you an example. See an event, understand that that's a malicious event, and it was like authenticated with the JWT, well, I'll reach out to the gateway and deauth that JWT and kill that person's session, right? Oh, another question. Thank you again. Do you capture all the traffic, including the bodies and headers? Some people have billions of API requests per month. Would that be a size problem? I will share the deck. By the way, I'm handling 2 questions. Second question that just came in, can you share the deck? I will. I generally tend to post all of my decks up on SlideShare, and there's an M Tesauro, my first initial last name user on SlideShare, and that's where all my decks end up. So I'll happily do that. And also, I believe these are going to be recorded as well. About capturing traffic. Yes, that can be, well, 2 things. One, I think you should capture all of the, you need the entire full request response pairs, including the bodies and headers. And yes, that can be size problematic. Now, one thing you can do is if you have the right kind of ingestion, you can start taking or optimizing the storage of that by doing things like the first time I get a request, I obviously have to store it. The second time I get a request, I can store the diff between that and the first one. So if it's the same request except for, say, JWT, then the only thing I really need to store is the JWT. So you can do those kind of engineering decisions to make the storage more efficient. And at least I can't speak for everybody's tool. I know some of our customers are very large customers and have shockingly big amounts of traffic, and our product can keep up with them. So this isn't like, vaporware, right? This really exists. Oh, and then finally, just to finish it out, right, you can also do just general sort of high level blocking, or I would call less granular blocking, right? Like geofencing or denying external traffic, right? If I see a public IP coming inbound to what should be an internal only API, maybe I reach out to a firewall and block that IP that was bringing it inbound or making that request inbound. Okay, so that's runtime security. And thank you for the questions, by the way. I love the questions. So the third pillar, testing, shift left, whatever you want to call it. And the whole point of this is to assess the security state of a running API, right? And I'm for the purpose of shift left, and particularly for an API security program, I'm taking SAST and SCA, or static analysis and software composition analysis, off the table, because if you have an existing AppSec program, hopefully you have those tools in place. And honestly, checking code for a web app versus checking code for an API from whatever tool you have to do that, this is really not much of a difference. So this is really focusing on dynamic testing of APIs. And ideally, whatever tool you choose allows you to call it from CI/CD or has APIs or something that makes that automation friendly. So you can do nice things like the first time I check in code to master, I can build a copy of that and then run a test against it, right? Way early in the dev cycle. Now for these tools, they have to understand the available methods of an API. And generally speaking, most of the testing tools that I've looked at want to take in some kind of a spec file, right? A Swagger or an Open API spec file. And that's good. And that's certainly better than not supporting testing REST. But that also means the quality of that DAST tool is only as good as the quality of that Open API spec. And there's a lot of things you can leave out and still have a valid API spec file, right? That would really help a tool doing testing, right? What do you expect to go into that string field, right? Is it just numbers? Is it numbers and dashes and maybe parens because it's a phone number, right? If that kind of validation information isn't in your spec file, the testing for the tool is going to be non-optimal, right? You probably will, if nothing else, send a lot of extra requests that you don't need to send. And ideally, you could either take like recorded traffic, the OSHU, what are they called? HTA files? I can't remember, the recorded HTTP traffic files, right? You can feed that into your tool as well if you have existing functional tests for your APIs. HAR files, thank you. Yay, look at this. It's interactive. This makes me happy. HAR files, thank you very much. I was forgetting those. So you can take those HAR files, presumably from something like functional testing, and use those to drive security testing. And then bonus points if you're doing monitoring of traffic in the runtime phase or pillar or whatever you want to call it, right? If that can inform your testing, you're one ahead, right? If the runtime tool understands what a normal request looks like and can feed that to your testing tool, you're getting that automatically, right? You don't have to do that little extra bit of work. And then at the end, you're going to find some things you never not find things, quite honestly. So how do I get the results to the right people, right? For the issues that can handle by dev teams, that's usually integrations with some sort of bug tracker, issue tracker thing like Jira. Maybe you need to have an integration with ServiceNow for the infrastructure side of the house. And the one thing that's really crucial, particularly for the developers trying to resolve these issues, is I need to see a full request response pair. One of the things I used to say when I was working product security at Rackspace was, if you ever want to have me, how do I say this nicely, put my foot where it doesn't belong, give a non-actionable finding to the dev teams, right? As a dev team, I need all the information to be able to fix it. And just saying my tool said this is bad and not giving you the full request response pairs doesn't really help. And I see a question, I'll get it in half a second. And then finally, I really like tools that have the ability to retest a specific issue, because inevitably in sort of the life cycle of getting these things resolved, the dev team will come back to you and say, yes, that issue 7, we fixed it. I don't have to rerun the whole DAST. I'd like to be able to just test for issue 7. The question that came in, any examples of good testing tools? So, boy, there's a lot. Obviously, I like ours, but I mean, I'm super biased because I work there. One thing I can tell you is there is this page on the OWASP website, API tools, security tools, that has these 3 pillars. And I have a long list of API tools here. I would suggest going there and finding this and giving it a look, because if you want to see these final ones, testing, yes, right? There's a whole bunch of them. I mean, obviously things like if you're manually testing, things like Burp Suite are great, but that's very, very manual. Zap has some good plugins. And actually either Zap or Burp really depends on the set of add-ins, plugins, whatever you want to call them, that you add to the tool that make it smarter about API testing. But that would be my 2 cents on testing tools. And then how do Zero Trust Network designs contribute to the API security program? Oh, interesting. Zero Trust Network design, are you doing the Zero Trust for the end users, or are you doing Zero Trust for the APIs themselves? If it's end users, it probably doesn't have too much to play except for who can actually access those parts of the infrastructure, and then like that's a huge win. But for API and backend, okay, thank you. It's like we knew. For API and backend, I've not seen Zero Trust principles. That would be really, actually, I could see that in some regards. An API gateway will act like an intelligent proxy, which is a lot of how Zero Trust works, right? You have an intelligent identity-aware proxy. And in essence, a lot of API gateways function in that same very fashion. And I think you'd get a lot of mileage out of having an API gateway to handle that auth in and auth Z. And the other big thing about auth in and auth Z for API gateways is that you don't have, if you have 10 APIs behind one gateway, I don't have 10 different code implementations of auth in and auth Z. I have one, and it sits in the gateway. Now, as long as that one's good, you've solved a lot of problems and you don't have developers repeating themselves, which is great. And then for east to west traffic, I think Zero Trust could be super useful in that, right? If you have the ability to identify a particular machine that a request is coming from and going to, and you can do that under sort of a Zero Trust idea, that's a huge benefit. One of the things I did years ago at Rackspace is we were testing the, there was a part of the compute cloud for Rack called, oh shoot, what was it called? Dang it, it was a private network between cloud instances within a single point of presence or DC or what have you at Rackspace. So if you deployed to Chicago and you had 2 servers in the Chicago cloud you could have traffic between those go over a private network that you didn't get billed for from a network usage perspective. So it was a great benefit to our customers. Well, we were testing that, and it turns out that every, at least in Rackspace's cloud, every communication between any hypervisor and any other hypervisor was in an encrypted tunnel. And so you couldn't do funny games like ARP spoofing and all that other stuff. It just worked, right? So if you have that kind of situation between API and backend, you're way ahead. Let's see, if my APIs are all encrypted, are these still necessary? Can tools still be used? So that's a great question. If all your APIs are encrypted, there's two ways you can get around that, just fundamentally, right? You can, if you're using a public cert for the public side of it, when you come internal and you're using an internal cert, the tool can have that internal CA built into it and can decrypt, right? That's one way to get around it. Two is to have a lot of deployments end up having the north-south side, the public side, being encrypted and the back end being unencrypted or encrypted in a way that I can break into it or duplicate that traffic. So that's the way to handle the API encrypted. So you can still do runtime with encrypted. You just have to have some special setup depending on how your network is configured. Whew, okay, this is awesome. What is next? Come on, you. There we go. So quickly, I'm going to run through very quickly the reason I'm talking to you is because I work for NoName. So I'm going to give you a quick overview of NoName and then move on. We are definitely a category leader in API security. We're in 20% of the Fortune 500s. We have over 75 integrations with a whole bunch of different pieces of infrastructure. And we do all three pillars or features or whatever you want to call it. We cover all three. We have a solution for posture. We have a solution for runtime. We have a solution for testing. And they're all a single platform. And so looking at this from the two perspectives, right, for a developer, I've got the shift left where I can do early testing. And the testing for NoName's product is pretty cool because I can test it down to a single API. And right by API in the NoName platform world, that means I can do it for a single host on a single path with a single method, right? If I need that focused of a testing, or I can test all the APIs, right? So you have this broad choice and it's under your configuration. For real time, we can identify and prevent API attacks on the developer side. And also we can do automated inventory based on runtime. And then for security teams, I can scale up that testing because it's automated testing and it understands how the APIs work because it's seen it in the runtime side of things. For the runtime side of things, there's a whole bunch of integrations with SIMs and other features that allow you to get that information out to the right teams in a quick fashion. And then for sustain, because it does that inventory, including data classification, I can write policies based on that data classification to understand where I need to focus my security efforts, and also write policies that can be enforced by runtime, right? Like I said, I don't want any credit cards ever leaving this. I should never have a public IP hit this. You can do those policies and have runtime enforce them for you. So like I said, we do all three, right? We protect APIs, we shift left, and we sustain excellence. This is the cool marketing slide. You can tell the ones that I didn't do because they're really fancy. This is also our architecture slide. So the idea here is we do, like I said, posture, attack prevention, and testing. And then if you look at the left, right, we have a whole bunch of development platforms we can integrate with to provide feedback to developers early in the process. We have a whole bunch of workflow integrations, Slack, ServiceNow, Jira, etc., right, to help you ticket these things that need to be addressed. We work with a whole bunch of different network and cloud providers to get data into our runtime. And then we have a whole bunch of API gateway integrations to be able to do things like automatically have the gateway take an action on your behalf if we notice some kind of anomalous behavior. This can be deployed on-prem, in cloud, or a hybrid of the two. And if you do a SaaS, for us, it's a single tenant SaaS. We don't share your data with any other company. Yes. And I've already kind of talked about this a whole bunch. So I'm going to just quickly cover it. We cover REST, SOAP, gRPC, and GraphQL. And we're continuously updating that inventory based on what we see in the runtime side of the house. One really cool feature is we will generate API documentation, open API or Swagger files based on the traffic we see. And we have tools to compare those. So you can actually do a comparison between what is what you think, aka what the documentation says your API looks like, and what you're actually seeing. Another question, API payloads are somewhat decrypted in trust zones. As such, most WAFs at perimeter are not able to do runtime checks on encrypted payloads. How do you suggest we handle this? So if you have encrypted runtimes, that gets really interesting. Depending on how your infrastructure is set up, a lot of times those encrypted payloads are being decrypted at a choke point, usually an API gateway. And if you're looking at the traffic behind that gateway, then you have access to it. You can also do things like have logs from the API gateway funneled to our platform and have it inspected in that regard. And by the way, we're out of band. I think I didn't explicitly say that, but we are out of band. So we're not like another network hop between your client and the API. Thank you for all the questions. This is awesome. For detection, we obviously detect abuse that's missed by gateways or WAFs. Although I think we play better with them because we can also do things like if you have a WAF in place and we see nefarious behavior, we can ask that WAF to say block that IP for an hour or whatever makes sense. We have context aware of all the data types because of the inventory. And this is one of the, well, just as an aside, I'm part of the OWASP Defect Dojo project. I've been doing that for 8 years now. And honestly, I wrote that as a product security person because I was tired of sort of vendors nudging me into the everything by the all vendor X's products for SaaS, DAST, and SCA, and it's one big happy solution. In some regards, I don't think that works very well for most security tooling. I think in the case of APIs, it does, because there's these interesting feedback loops between the different pieces, right? Runtime can update inventory. Testing can add traffic to runtime. Runtime can tell testing how to test, right? You have these interesting loops between the different pieces of the platform, and they actually are better all coming from one platform than rather to piece them out. I think, good God, if I had to make a bunch of these things talk nicely together, it would be a nightmare. Ooh, and I'm running short on time. I just looked at the time. I talked about TAC. I talked about shifting left. We do integrate with CI/CD repositories and CI/CD pipelines. We can do event-based testing or manually trigger testing. One of the things we do is we create an inventory of all of your APIs, and you can group. We do some auto grouping, particularly by host and things that are easy to do, but you could also group them yourself. So if you had 3 APIs that made up a product, you could group those and then test that product as a whole or any single API within that product. So it's pretty nice, the granularity of testing you get with the NoName's platform. And then from there, you can take those results and push them directly into Jira or whatever workflow-based system you have. Okay. NoName is also now a TAP partner with F5. Oh, thank you for telling me that, or telling us that. F5 can handle and decrypt the streaming copy of the traffic to the NoName product. Yeah, that's a great point. A lot of those decrypting traffic depends on your network infrastructure and integrations with those pieces of network infrastructure, because with those integrations, we can sort of solve those encrypted payload or encrypted traffic problems. Thank you for that, Todd. Okay, other considerations, our final section. I like to, this was a slide I used, or a copy of a slide I used for a talk at an OWASP chapter, but I really think it's important to think about when you're dealing with APIs, you end up having this stakeholder soup, right? If you have a mobile app and a web app that's fronted by, or that's in front of APIs, right? And I have issues, I may have to talk to the mobile team, I may have to talk to the product team. It may be a problem for AppSec. It may be a problem for network ops because of the F5 integration, like we just mentioned, right? It may be InfoSec. There may be an IAM team who's managing identities, right? All of these different constituencies in a large organization have to play nice together and make things work. And as someone running an API security program, you have to understand how to talk to all those different constituencies, including the onion there. I had to throw that in, a little throwback reference to my Shrek slide. And then also when you're considering tooling, I already sort of mentioned this, but you need to make sure that that tool speaks whatever language you have now and whatever language you may have in the future. So if you have a GraphQL only tool, but you have GraphQL and gRPC and REST, well, you've only got like 1/3 coverage. That's not so useful. Okay, let's bring it all together. And I got to take a drink because I've talked for 47 minutes and my mouth is dry. Okay, bringing it all together. And I love the questions. This has been fantastically interactive. So as you're building out this API security program or your journey, right, you can actually get some good early wins simply by getting a good inventory in place. Because with that baseline, you can start making intelligent risk decisions about what needs further inspection, right? Like having done this at a bunch of different places and run AppSec teams, it's really hard to understand what you should focus on if you don't have the full landscape. So I know inventory is not tremendously sexy, but man, it's useful. And so once I have that inventory, I can start doing things like establishing policies, like data policies, right? Like I said, credit cards should never leave. HIPAA data should only be intra-service. It should never go public. I never want a public IP to hit this endpoint, right? All those things can happen now that I have a good inventory. And then you can take those policies and start to enforce them and start to operationalize what happens when a policy is violated, right? Do I submit a ticket into ServiceNow and have one of our team go off and look at it, right? Am I going to automatically reach out to F5 and block that IP for an hour, right? Those are things you can do now that you have that baseline established. And then for a lot of our customers, what ends up happening is they'll maybe, like they have a complicated setup where they may have some APIs on-prem, some APIs in AWS, and maybe some APIs in GCP, right? They may start the program with all of their APIs in, say, AWS, and then now scale that out. I want to also now talk or have the same API security program for what's in GCP and also what's on-prem, right? Once you have that sort of total view, then you can start to optimize and really have those nice feedback loops to the product teams to keep things secure. Ooh, I'm close on time. So 4 key takeaways. APIs are complex. They're going to grow over time. They have multiple constituencies and multiple systems. So it is a bit of a complicated space. API security needs to be considered from those 3 perspectives: posture, runtime, and testing or development assurance. API is going to have high coordination between a bunch of different teams because a lot of players have a piece in this pie. Whew. And then visibility, right? You really need visibility across all of the API landscape so you can start making intelligent and focused decisions. This is me. Ooh, thank you, with 37 seconds over, and I apologize for running late. But this has been fantastic, man. This is great. I love when I get questions. I hate when I talk to a screen for 50 minutes. I believe the conference is going to make a recording of this session because I was asked if I was okay to have it recorded, and I said yes. I do not know when those are going to be produced. Having done conferences before, it usually takes a week or so to get those out. So there you go. Oh, we got a nice link to the F5 Alliance with NoName. Thank you for that. Whew. Absolutely. Thank you for the, I just got to thank you for the session, by the way, and thank you for all the questions. I love getting questions while I talk on these things. Makes it so much better.